Yeah, let's get started. So, this is very just to have a refresh of these things. Uh, Given a matrix A, what is the rank, right? So, just to refresh, what is the rank is number of linearly independent columns or rows, right? So that's the rank of the
Excuse
matrix.
me,
Yes.
the screen is not visible.
For others, is it visible?
No, it is not.
No, no, it does not.
Okay. Is it visible now?
Yes, now it is visible.
Yes.
Okay. Yeah. So given the matrix A, how do you find the rank? Right. So what is the definition of rank? I mean, it is the number of linearly independent rows or columns. Right. So I mean, given a matrix, how do you find rank is you take the determinant and then if it is non-zero, then the dimension of the matrix is the rank, right? So yeah, so that is, if you do that, you will find the determinant of this is non-zero and hence its rank is 3. Um, any questions on this?
No.
No, right? Yeah, because when I share, I cannot see the chat.
Yeah.
I urge you guys to speak. Okay, so this is where we start the perceptron thing. So given a positive and negative examples, such as in this figure, so I've cited the source of this figure in the bottom. You can go out and look. Um, so the task of the typical machine learning or deep learning algorithms is to find a classifier um, or find a way to separate out these points, positive and negative example, right? So this X represents the data points, that is green or the cross marks, right? Um, so your task is to come up with W and a B given this data points, the cross marks and O's, right? Um, so this is a typical example of the classification task where you want to find a hyperplane, right? What is a hyperplane? Here, this W transpose X plus B. So dot of X comma B is nothing but W transpose X, right? So that's the typical Python notation to represent this. I think there are few people waiting. Done. Okay. If you guys have permission to add somebody who's waiting, please keep adding them. Okay. All right. So that's what is machine learning is or deep learning is all about, right? You classify the set of um, points with its associated labels. Uh, so what perceptron does is very special case of this task when the data is linearly separable, right? Then you have an algorithm called perceptron that finds this hyperplane that can classify the data. Classify the data above this hyperplane, you have one set of examples. Below this, you have another set of examples. That's it. Okay. So um, now this is a simple data set where you have city A associated with temperature, humidity, and city D associated with some other temperature and humidity. Now, can can we um, split this data with a straight line or a hyperplane, right? I mean, it is very easy to see this data. You can split this because there is per city D, you have a negative side, right? So y-axis is the line that can separate all these data points. Okay. Any questions? Why that y-axis is the point that can separate out these data points? I can explain it if you have a question.
Sir, is it because it is on the
Exactly.
negative side?
Yes, it is on the negative side. The rest of the points are positive. It doesn't matter where the y-axis points are. If you put a straight line, I mean that is y-axis, then you can separate out this point,
Okay, sir.
right? That line, to the right of the line, you have all city A's. To the left, you have city D. So that's why that is the that's why this data is linearly separable. So linearly separable is you draw a straight line where you can separate the labels. That's it. Okay, so yeah, what is a perceptron algorithm, right? So here, to the positive side, you have this condition satisfied. W transpose X plus B is positive. To the negative side, you have this W transpose X plus B is negative. Right? So perceptron makes an update only when you make a mistake, right? And it keeps on updating, right? So here, this condition implies that you made a mistake here. The wherever is my arrow, if you can see, this is a condition that if there is a mistake, you update and you update the number of mistakes or number of updates. Basically, you update only when there is a mistake. So number of updates are number of mistakes that a perceptron algorithm makes. So you keep making these updates as till you make mistakes. When the data is separable, perceptron is guaranteed to return the point W, which can classify all the points correctly. When the data is not linearly separable, it will not work. Okay, so this is the algorithm of perceptron. So let's go to another question. Right. So yeah, this is a simple question. We should be able to answer this. What is the perceptron algorithm used for? Right. Clustering is not the point. Finding shortest path is not. Classifying data,
Mm,
yes, it's correct.
yes.
To be precise, classifying linearly separable data. To be very precise. Right. If I give you some non-linearly, I mean, if I draw say two circles, if I draw a circle and points below the circle are, let's say, are green, points above a circle are red. Now, if you ask perceptron to come up with a circle, it will not come. Okay. Even there, the points are separable, but it's not linear. And yeah, what is the common activation used in perceptrons. Basically, it's not an activation. So this is why the term activation is called as typically the positive points are labeled as +1 and negative are labeled as -1. So basically, what you do is to classify, you put a sign function on this thing, right? Sign function on dot of this thing. So sign of some positive is +1, sign of negative is -1. So that's the reason this is called as step, right? Anything positive, you call it +1, anything negative, you call it as -1. So I think let me be better if I draw. Okay, so this is what I mean. So if there is anything positive thing, you call it as +1. And if it is negative side, you call it as -1. Okay, this is what the activation it meant. And the other example I was giving is, see, if you have a data like this, right here you have cross, and outside you have zeros. And if you are expecting perceptron to come up with a circle that can separate out this X's and O's, it is not possible because it can only separate linearly separable data. And linearly separable data is, if you draw a straight line, it should be able to separate the positive points and negative points. The positive and negative are nothing but just X's and O's. You can imagine that's it. Some labels. That's all. Clear?
Yes, sir.
Let's go to the problems and the problem. There anyone waiting in the lobby? I don't know. Do you see this? Okay, cool.
Sir, I have one small doubt.
Yes, yes.
Sir, I have watched the videos, but can you explain a little more about why we are having weights in perceptrons, sir?
Weight says
For the yes, sir.
basically the problem is this, right? All you are given with X, the data,
Yes,
that's all,
yes.
and associated labels. For for
Mm,
green, let us say this circle I'm giving you +1. This circle,
mm,
all these green circles are +1, and all
mm.
red points as -1. Your aim is to come up with W, this line, W transpose express B, right?
Mm.
This line. So how do you come that W and B is what we call as weight.
Okay.
If you are imagining something else as weight, then this is not the right answer. You have to clarify the question,
Mm. Okay.
right?
Yes, sir.
So you want to learn these weights, W's and B's. So that is what
That is,
all
first it
this
will be
all the activity.
unknown, sir. First we won't know, we won't have any idea about the weights, but
Right,
as we solve, we will come to know.
right. So you have given you this algorithm, right? You keep running that. You start with some zeros or some random number, then
Yes.
you will get convert to that weight. When you will
Okay.
convert, if you have a data that is linearly separable, right? If I give you circle kind of data, it will not.
Mm.
Okay, so that's it. Um, Yeah, so I told you why this why this activation is called as step, right?
Mm. Yes.
Um, so yeah, which Boolean functions cannot be implemented by perceptron? It is pretty easy to see. Uh, it is XOR actually, right? So
Mm.
why I'll tell. You can see. Let me share that thing. Right. So what is XOR? Right. Here you have say points, small points. So this is called as zeros. Some small points and some high points called as some ones. You can think of say high and low. That's it. That's better. High and low. Okay. And y-axis is also high and low. That's it. So what is XOR, right? When you have two positives, you get zeros. When two negatives, you get zeros. Right? One positive, one negative, you get plus one.
Mm.
One
Yes.
positive, negative, you get plus one. Now there is no straight line that can separate out ones and zeros,
Mm.
right?
Yes.
That's a
Yes.
perceptron cannot um classify the XOR data, XOR kind of data.
Okay.
Okay,
Mm.
and so this is the data. Again, you have to see if you can linearly separate it or not. So basically, you have to draw these points, and
Mm.
then you see like if you can draw a straight line such that ones and minus ones are separated or not. I think in this case it's no, but
Mm.
basic idea is that.
Mm.
And, right. So this is question. Here the input dimension is 5. That means you have a vector of 5 inputs, x1, x2, x3, x4, x5. And we have a perceptron with all ones, 1, 1, 1, 1, 1. Right? So basically, what perceptron is doing is it is adding x1 plus x2 plus x3 plus x4 plus x5. And your inputs are Boolean. That's why it takes zeros or ones. So how many possible inputs give an output y? So let's try to solve this. Right? So y is nothing but theta transpose x. Theta is all one. X is x1, x2 to x5. Right? This
Theta
is nothing but
is the weight
x1,
vector, right?
x2 plus x3. Yeah, theta are weights, W's. Right? It's just a notation change here, right? Now, how many different kind of inputs give me an output of y to be 1, right? So for a Boolean kind of input, how many possible inputs are you can have how many possible inputs, right? X1 can take 2, 0 or 1, x2 can take 2, 0 or 1, x3 can take 0, same thing. That is 2 power 5, right? So only place where you get y to be 0 is when all of these guys are zeros, right? in all of that place you get an output one. The output one again it is you declare an output one if it is the sum is greater than zero, right? Theta transpose x is greater than zero. Otherwise it is zero or minus. So this is the total number of possible inputs are 2 power 5 minus 1. So that is 31. Okay. Any questions on this? No, yes, I can go over again if there are any questions.
I had a question.
Yeah. On this
So,
problem?
on this kind of problem only.
Yeah.
Say if one of the inputs is inhibitory, does that mean it will not give the output as 1, or we should try a different combination?
Can you come again? What do you exactly mean by inhibitory?
I'm inhibitory input, as in like x1, x2, x3, x4, x5, any one of them being inhibitory input.
Inhibitory means what kind of values it takes or what I did not get the question. The adjective inhibitory I did not get. What do you mean by that?
So, like, inhibitory input means it's like it takes negative value.
Okay,
That's how I
fine.
understood it. I hope I'm not wrong.
No, even I mean we learn from different sources, so that's fine. Yeah, you mean by large negative values, right? That's what it is. Right.
Yeah.
That's what you mean by inhibitory, right? No, see here the inputs are just boolean, right? You can have x1 to be either 0 or 1,
Okay.
right?
Okay.
Yeah. Is there any other context to your question? Um, if it
No,
is, I
no,
can clarify right away. No?
no.
Okay, then
Thank you.
so let's move on to
Sorry,
something.
sorry.
Yeah.
Why are we assuming that if x1 plus x2 plus x3 plus x4, x5 is greater
Uh,
than 0, then the output will also be y plus 1? Why are we assuming that?
no. So not assuming how should I put it? So basically, this is the data. So this point belongs to say positive label. Okay, although it is residing in two-dimensional space, right? So you call it as plus one. So there is an associated function with every input, right? That you are trying to discover through the data. So that's why when you want to learn this kind of mapping, right? So green should go to 1 and cross should go to -1. To learn that, you are coming up with some function. So in this case, this linear function works, but if not something complicated, we will go, I think, as you go into the course, you'll learn things. Right. So for this simple function, W transpose X, for this simple data, W transpose X plus B kind of function works. Now, when I call it as plus 1, if it is greater than 0, I call it as plus 1. Because if you see any X, it makes a positive inner product with this vector. Okay. So don't confuse with the labels with the data. Any questions?
Sir, I have just one doubt, sir. I'm
Yeah.
just asking out of curiosity, what if we have theta is equal to 2? Like, in this question, we have theta is equal to 1. We have different number means like how?
Any theta you can take, right? Any theta positive, you'll get the same answer. Okay, so if theta is 2, let's say theta is 2, right? What you get
Mm,
is 2 times this thing, right? Even
so-
then, your thresholding function, right? It throws away 1 whenever this sum is positive.
yes.
What is interesting is if you put theta as -1, -2, +3, -4, right? There you need some work, right?
Mm-hmm.
It's not completely trivial to say,
Okay.
right?
Okay, sir. Yes.
Yeah, you have to compute this inner product. Instead of all ones, you have to put this kind of vector and then put x1 to be 1, 0, 0, and wherever it is positive, those examples are classified to be +1. Wherever it is less than or equal to 0, call it as -1,
Okay. Yes, sir. Thank you.
right?
Excuse me, sir.
Yeah,
If I'm not wrong, we are assuming that our activation function basically takes the output of x1 uh, transpose x vector, and
right.
we apply the step function. Depending if the result is greater than 0, we label it 1, and if it is less than 0, we label it -1,
That's correct. Yeah,
right?
right.
Okay.
Okay, so yeah, this is very simple question. I mean, what does artificial intelligence represent, right? It's not a repetitive task or something, some communication between machines. It is something that normally require human kind of intelligence. That's all. Um, yeah, so this is interesting question. What, which of the following statements are true about error surfaces in deep learning? Any guesses? So there are too many complex jargons here. Convex functions. So how many of you are familiar with convex functions? And local minimum. And I think linear functions we just saw like the perceptron kinds of function, right? So they are linear. Um, right. Do you know what is convex functions? If not, I can quickly tell what it is. Speak out. I cannot see the chat. That's what I said. No, yes, yes, no.
Yeah, please explain convex functions.
Okay. Okay, so this is a function, right? This is a convex function. So what is one geometric? I'll not write some equations. I'll tell you geometric intuition. Uh, you draw a straight line, right? This line should be above the point, above the function where it intersects, right? Between these 2 points, x1 and x2, right? Your f of x, this is f of x, right? This part is f of x, and so we call FL of x. and a straight line. So any this should satisfy for all x1, x2, right? Wherever this function is defined. So that is to precisely write this f of alpha times x1 plus 1 minus alpha times x2, right? And this is less than or equal to alpha times f of x1 plus 1 minus alpha times f of x2. Okay, so this is your convex function. Right? Any for all x1, x2, wherever this function is defined. So basically, f of x1, x2 is any points between this. This alpha times 1 minus alpha. Alpha is between 0 to 1. Right? So it just finds any point that is, if basically if alpha is 0, you are at x1. Sorry, alpha is 1, you are at x1. Alpha is 0, you are at x2. Right? For all the points between this, your straight line should be above the function, right? So that's what it is. This is geometric infinity. This is how we write the math. Yeah. So basically, losses in deep whatever happens in deep learning is you create a loss function. It is a function of your inputs and your weight, right? And you average over all your inputs. Right, 1 over say n data points if you have, right? So this is some function of w, right? So when you view this function, when you view this loss as a function of w in deep learning, it is not at all convex. Okay, that means this property is not satisfied. It may satisfy it somewhere locally, but it will not. Okay, so that is convex function. Even more worse in deep learning, basically, even if it is again you will know like if it is under parameterized and over parameterized, that means when the dimension of w is much more than x, which is over parameterization, right? More than input. And when your dimension of w is much less than inputs, right? Then this geometry differs. Maybe we can discuss as the course goes along, right? In the subsequent. But for now, this is what it is convex, right? Can we come again? No questions, questions. Okay. So basically what happens in deep learning is the loss functions are typically like this. It is not like this. It is something like this. Right? You have multiple minimums, local minimums. Okay. So yeah, the last question. Okay, for today's you're given the complete multi-layer perceptron this thing. All right. You basically weights are all ones. So theta transpose x is x1 plus x2 plus x3. And you're given the decision rule also. I just need to find which of the following is true, right? So wherever it is one, um, this is true because two is greater than or equal to one, and this is true. That's it. So yeah, this is all the problems that I have for today. If you have any questions that I can that we can discuss or any doubts on perceptron quickly, I can clarify.
Yes, sir, I am having doubt on question 6.
Question six. Yeah, question six. Yeah, yeah. I
Yes,
haven't
we
drawn
can
this,
draw.
but yeah,
Yes, we can draw a line y is equals to 3, which can separate out the points.
y is equal to 3.
Yes.
Okay, let's check. You tell me the points and labels. Let's try to uh, see that. Yeah, tell me what is the first point.
2, 4.
One, two, three, four. Yeah, 2, 4. What is the label?
Positive label.
Okay, so call positives as O's. Okay. Then
Then 3 minus 1, negative label.
3 and minus 1. We call it as X. Okay.
Then 5 and 6, negative label.
Okay. 5 and 6.
Yes.
5 and 6 is somewhere in the top. Okay. We call it
Hmm.
as X. Yeah.
2 and 0, positive label.
2 and 0 positive. Okay.
Negative 1 and 0, positive label.
Negative 1 and 0 is again positive level. Okay.
And minus 2, positive label.
And minus 2 and minus 2 is again positive level. Okay.
Yes.
Hmm. So looks like y is equal to 3 can separate out the positives, right? And negatives. Just give me a minute.
Okay.
Yeah, I think yeah, then it is separable. Not just anything three, right? Anything between two and three, you are able to separate. I think. Right? On this side you have negative, and this side you have positive. Okay.
Hmm.
Any other questions?
Mm-hmm. Wherever you land up. Thank you.
So can we get the recording of the session?
Recording, yeah. So I'll upload by Monday or Tuesday. So this happens, I think, every Saturday, right? Till I think 12 weeks. So if it happens on Saturday, by Monday or Tuesday, I'll upload, and you'll be given the link.
Okay, sir.
Okay. So let's okay.